Welcome back to Secure 7, and today we're diving deep into one of the most dangerous but often overlooked OWASP top 10 vulnerabilities: software and data integrity failures. This vulnerability doesn't rely on brute force, password guessing, or even misconfiguration. Instead, it exploits the trust you have in the software you use and the data you rely on. We'll explore real-world examples like the SolarWinds hack, walk through a demo showing how this works, and most importantly, learn how to prevent it. Grab a coffee, sit tight, and let's get started. What is software and data integrity failure? So what does this term mean? At its core, software and data integrity failure occurs when applications or systems fail to verify the integrity of software updates, libraries, or critical data. If your system downloads a file or update and assumes it's safe, without checking its authenticity, attackers can exploit this trust. Think of it like receiving a sealed letter. If you never verify whether the seal is genuine, anyone could slip malicious content inside. Some common cases include applications using unsigned or unverified software updates, dependency confusion, pulling packages from untrusted sources without integrity checks, continuous integration pipelines with weak access controls, apps loading external resources like JavaScript libraries directly from a third-party CDN without verifying a checksum or signature. This is how attackers launch devastating supply chain attacks. Let's look at some real-world incidents. SolarWinds supply chain attack 2020. Hackers compromised the SolarWinds Orion update system. Organizations like Microsoft and several U.S. government agencies installed the Trojanized updates, allowing attackers to infiltrate their networks. Event Stream NPM package incident 2018. An attacker added malicious code to a popular JavaScript library, stealing cryptocurrency wallet keys. Kodakov Bash Uploader 2021. A malicious update sent sensitive data from CI/CD environments to an attacker-controlled server. What's common here? The attacker didn't exploit the victim directly. They compromised a trusted source. Here are the main reasons this vulnerability occurs. Close quote bot 1, unsigned or improperly validated updates. Many applications don't check digital signatures on software updates. 2, untrusted dependencies. Developers often pull packages from open source repositories. If an attacker uploads a malicious package with the same name as an internal one, dependency confusion, it may get installed. 3, weak CI/CD security. If an attacker can modify build pipelines, they can inject malware directly into production code. 4, no sub-resource integrity, SRI. Websites loading scripts from external sources without integrity checks allow attackers to inject malicious JavaScript. Impact of exploitation. Attackers can execute remote code on victim machines, steal sensitive data, credentials, and encryption keys, deploy ransomware across thousands of systems simultaneously, compromise a single vendor, and impact thousands of customers downstream. This is why the SolarWinds hack was so catastrophic. Open quote, what's the worst that can happen? Close quote. How to prevent it? Luckily, there are strong defenses against this vulnerability. 1, code signing. Always verify the authenticity of software updates using digital signatures. 2, sub-resource integrity, SRI. Add integrity attributes to externally loaded scripts. 3, pin dependencies. Lock versions and use package checksums. 4, CI/CD hardening. Implement MFA and restrict access to your build pipelines. 5, regular security audits. Monitor open source dependencies for known vulnerabilities. To wrap up, software and data integrity failures are deadly because they exploit trust. Always verify updates, check dependencies, and secure your CI/CD pipelines. If you learned something today, like and share this video, and subscribe to Secure 7 for more in-depth OWASP top 10 tutorials with real demos. Next up, we'll cover security logging and monitoring failures. Stay tuned.